Alright guys, today we're going to start the circles unit. Alright, I was not able to be there today because I'm at Leadership Workshop, but hopefully we've gotten YouTube issues worked out and you're able to be watching this on your own. If not, you'll be watching it obviously with Mr. Mitchell running it. I'm going to go through it fairly quickly, but if you're on your own, you can actually slow it down, rewind it, pause it when you need to copy something. If you're watching it with Mr. Mitchell, he's able to do the same thing for you. Alright? Well, to do circles, today we want to start just talking about the basics of circles. Circles is going to take us all the way to spring break and for a week after spring break. It's a very long unit. Alright? But to calculate anything in a circle, we first need to understand the parts of the circle. Alright? And how we name them. Well, the most basic part of the circle is a circle is the set of all points in a plane equidistant from a singular point, which we call the center. All right, and for example, we have our circle over here. We name the circle by whatever the center point is. For example, this one we would call circle C. Now, you can either write it as circle C, or we denote it with a circle, but you have to make sure that you put the point in the middle. Otherwise, it just looks like an OC, okay? So we can either write the word circle and then C, or we denote it with the circle and then the C. Now, within the circle, we have different types of segments. The smallest segment and the most basic segment of a circle is the radius. The radius is a segment whose endpoints are the center of the circle and a point on the circle. A segment whose endpoints are on the circle, or in the center and on the circle. So for example, we have segment CE, which is a radius of the circle. Now, how many radii, because that's plural, do we have for this circle? Well, as many as you can draw in, okay? Any segment, there's an infinite amount of radii in a circle. As long as one endpoint is on the circle, and one endpoint is in the center of the circle. Okay? Now, if I take that radius and extend it, we'll come back to that. The next bigger segment in a circle we call a chord. A chord is any segment whose endpoints lie on the circle. For example, here I have segment B. Both of these endpoints lie on the circle. And again, just like the radius, there's an infinite amount of chords in a circle. Okay? As long as both endpoints are lying on the circle. Now, if we just happen to take one of those chords and we cut it through the center of the circle, that's when we get a diameter. A diameter is a chord that passes through the center of the circle. So for example, here we have segment BH. Okay? So a radius starts at the center and goes to the outside. A chord, both endpoints lie on the circle, and then a diameter happens to be a chord that cuts through the center. Those are the three segments of the circle. Well, along with the three segments, we also have lines of the circle. The first line of the circle we call a secant line. Now, notice where that secant line popped up. I'll flash it here a couple more times so that you can see. Notice it's lying right on top of the chord. Okay? A secant line is any line that intersects the circle two times. That means a secant line will cut into the circle and then back out. But this is why notation is very, very important. Because if I have the segment from B to E, That is my chord of the circle. But if I extend that segment infinitely into a line, BE, line BE, now becomes a secant line. So if it stops at the endpoints on the circle, it's a chord. If it extends through and continues, it's a secant line. So notation is key. If you put the wrong bar on top, it's completely wrong. The other type of line we have is a tangent line. A tangent line is any line that hits the circle exactly one time. All right, so for example, if I look up there at the line AG that popped up, notice it comes in. It's basically like if you took a spaghetti noodle before you cook it and laid it on top of a basketball. All right, it's not going to cut through the basketball like a secant would. It's just going to lay on top. It's going to touch that ball at that one point. And we call that point the point of tangency. That's the point at which a tangent line intersects the circle. So for example here, we have line AG, which is the tangent line, and point G, that's your point of tangency. That's the point at which it hits. Okay? So, again, I'm going to move through this kind of fast. Pause if you need to. So you guys try. Pause the thing, try labeling it, and then play. So here are the labels you should have come up with. The center point is C, so we named the circle, circle C. Chord. You could either have segment AB or segment DE. Even though the DE looks like it's a line, it's still technically a segment as well. Line FG is your tangent. For the radius, you could have had segment CE, segment CD, or segment CG. But notice how each one of the radius start. You start with the center point. Okay? So anytime you name a radius, you always name all radii from the center. For a secant line, I have line DE, but for the diameter, I have segment DE. Remember, notation is key. If you get the notation wrong, it's completely wrong. And your point of tangency is G. So, diameter versus radius. You guys should know by now that your diameter is twice as long as your radius, or you can also look at it as the radius is half the diameter. So, if somebody gave you a diameter and said, what is the radius? For example, if I asked if the diameter is 13, what's the radius? You would say the radius is 6.5 inches. Remember, quotations mean inches. If the diameter was 8 centimeters, the radius would be 4 centimeters. If the diameter was 12.6 feet, the radius is 6.3 feet. And again, an apostrophe stands for feet. If it was 2 feet 7 inches, it would be 1 foot 3.5 inches as the radius. And I just go in reverse if they give me the radius and want the diameter. If the radius is 17 centimeters, the diameter should be 34 centimeters. If the radius is 6.3 feet, the diameter is 12.6 feet. 0.75 millimeters radius would be 1.5 meters as a diameter, and 4 3/4 would be 9.5 inches for a diameter. Okay? The radius and diameter is very simple conversion. Cut it in half to go from diameter to radius, multiply it by 2 to go from radius to diameter. Circumference. Again, something you guys already know. we know that the circumference of a circle equals 2 pi r. 2 pi times the radius. However, remember, multiplication is commutative. So if I multiply the 2 and the r together, that's the same thing as saying the circumference is pi times the diameter. So that way, if they give you the diameter, there's no point in wasting time cutting it in half to get the radius, then stick it back in just to multiply by 2 again. Okay? So, if I want to find the circumference, and I have 13 inches as the diameter, well, the circumference is just 13 pi inches. All right? Now, some of y'all might be clamoring for your calculator saying, well, I got to punch in 13 pi. No. Leave your answer in terms of pi. Okay? And one big thing, never do. We do not use 3.14. 3.14 is middle school pi. We use pi. On your calculator, if you notice, right above, well, let me circle it. But right above the arrow key, which is above your division bar, in blue, right below clear, you see the pi button. That's the button we use. We do not use 3.14. So if they wanted this in decimal form, I would punch in 13 pi, hit enter, and I would have 40.84. Okay? But if it doesn't say that, just leave it in terms of pi. All right? So if my radius is 4, again, for radius, it's 2 pi r, so I would double the radius, which is 8, and I would get a circumference of 8 pi centimeters. If my diameter is 2/3, well, my circumference, now when I multiply 2/3 times pi, remember, just like anything else, it's pi over 1, I would get 2 pi divided by 3. And if my radius is 3.5, double that, I get 7. I get 7 pi meters. Okay? So, pause the video and you guys try these four. And here we go. Diameter was 7.3, I get 7.3 pi as the circumference. Radius is 6/5. Well, remember, if I double 6/5, that's 12/5. And then I have to multiply it by pi, so I multiply it to its numerator, and I get 12 pi over 5 centimeters. If the diameter is pi, well, that's pi times pi. Well, anything times itself becomes a square. So that's pi squared meters. And lastly, if the radius is 0.7, double that to 1.4, I get 1.4 pi feet. Okay? Again, if you need to back it up and look at it again, do so. Now, what if we want to go backwards? Say, for example, we're given a circumference of 12 pi meters. I want to find the radius and the diameter. Well, if you're given a circumference, it's always easiest to find the diameter first, because once you find that, you can cut it in half to get the radius. So if I have a circumference of 12 pi, well, if circumference equals pi d, to solve for the diameter, I just simply need to divide by pi, don't I? And my diameter will be whatever the circumference is divided by pi. So, if I have 12 pi, if I divide this by pi, the pi would cancel, and I would get a diameter of 12 meters. Then, once I have the diameter, I would cut that in half and say the radius is 6 meters. Easy enough? The second one has circumference as 6 pi divided by 7. Would I change anything? Absolutely not. I would divide by pi, which would allow me to cancel these two. And that would give me a diameter of 6/7 feet. Now, when I need to cut that in half, well, if I take 6/7, cutting in half means I'm multiplying it by 1/2 because it's dividing by 2. Well, that's 6/14, and this would reduce to 3/7. So my diameter is 6/7, my radius would be 3/7. For the last one, I have the circumference is 50.27. Would I do anything different? No. I would still divide by pi. The only thing is now you would need a calculator. So we're going to take our calculator. We're going to do 50.27 divided by pi, not 3.14, but pi. And I get 16.001437. All right? My suggestion is always rounded to 2 decimal places. So that means my diameter is 16.00 meters. Now, some of y'all may say, well, what do I got to put the zeros? That's stupid. Nah. The problem with it is if you don't put the zeros, if you just write 16, you're telling the person that's reading this that it's exactly 16 on the nose. But we know by what's in the calculator that it's not exactly 16. You round it to 16. So you need to at least put a 0.0 to show whoever's looking at it that you rounded it there. It's not exactly that value. But when I go to cut it in half, same concept, I would get 8.00 meters. Okay? All right. Well, along with the segments of the circle and the lines of the circle, we also have arcs of a circle. And you have 2 different types of arcs. You have your smallest kind of arc, which we call minor arcs. Minor arcs are any arc of a circle that measures less than 180 degrees. Any part of the circle. That means arcs can only be denoted by the points that lie on the physical circle itself, not anything inside of it. But it has to measure less than 180. And we denote an arc by putting an actual arc above the letters. Okay? If you do not put that arc, it means something different. Because now, if we have something like CH, you can, or if I write the correct letter, you could have line, segment CH, line CH, arc CH, okay? The length of CH. All of those are different things. So you have to make sure that you write the correct abbreviation, or the correct notation. So if I looked at this circle, if we talk about CH, C starts here, goes to here. That's less than 180 degrees, because 180 degrees would be half the circle. This is less than half. So arc CH would be one minor circle. I also have examples like CF, FG, even GH would be, even though it's a larger one, it's still less than half the circle. I think there's other ones, like CG is one as well. Now minors, they're less than 180. Major arcs, those are greater than 180. A major arc is any part of the circle that is larger than or greater than 180 degrees. For example, if I start at C and I go all the way around to H, that's more than 180, but less than 360. You don't want to make a full circle. That would be a major arc. However, would I call it arc CH? Because if I did, well, how do I know? Is it major arc CH or is it minor arc CH? I wouldn't have a definite answer. That's why with major arcs, you must use 3 letters to denote it. Minor arcs, you simply use 2 letters. For minor arcs, you use where do I start and where do I stop. When you use 2 letters, you're saying, here's where I want to start, here's where I want to stop, and I want to get there the fastest way possible. That's my minor arc. With the major arc, you need to use 3. You need to know where do you start, the direction you're headed in, and where do you end. So for example, if I look at that major arc, I might want to start at C and end at H, but I want to go in the direction of F. So that's major arc CFH. You also could call it arc CGH. These are the exact same arc. They have the same starting and stopping point, and they go in the same direction. Some other major arcs might be GHC. FGC is another one. Well, minors are less than 180, majors are greater than 180. So in the middle of that, we have a semicircle. Semicircles are the part that are exactly 180 degrees. Semicircles are the part that are exactly 180 degrees. So if I look at this, well, I see I have a diameter. So if it's exactly 180, the endpoints are going to be the endpoints of a diameter. And I have diameter FH. So could I just say arc FH? Well, I could, but do you mean start at F and go to H this way? Or do you mean start at F and go to H this way? I have 2 semicircles there. I don't know which one you mean. So, just like with major arcs, you must use 3 letters to denote a semicircle. So, I can either have arc FGH, which is the green one, or I can have arc FCH, which is the blue one. Okay? So for minor arcs, you need to make sure you only denote them with 2 letters. Where do you start? Where do you stop? Because they're the fastest way. Major arcs and semicircles, you have to have 3 letters. Where do you start? What direction do you want to go? Where do you end? Okay? Alright. Now I know this seems like a lot that's coming at you today. This is a lot of the different parts of a circle. Okay? But most of these things are fairly simple. So far we've talked about how to name a circle, the different segments of a circle, the different lines of a circle, and how I can calculate diameter, radius, and circumference. Then we talked about the arcs of the circle. And the last thing we want to talk about is one of the angles of the circle. Now there's 4 different types of angles in a circle. Central angles, inscribed angles, inside angles, and outside angles. Today we're just going to do the easiest one, the most basic, and that's a central angle. A central angle is an angle that is formed by 2 radii of the circle. A central angle is an angle formed by 2 radii of a circle. That means its vertex is always the center of the circle. Its vertex is always in the center of the circle. Now, if I want to find measures of them, The key thing to understand is central angles equal their intercepted arc. I can't spell. Central angles equal their intercepted arc. Central angles equal their intercepted arc. So, for example, if I want to find the measure of arc BC, I'm going to come over here and I'm going to say, okay, here's my arc BC. I start at B, I go to C in the fastest way possible. If I take those two endpoints and I follow them down, I see they're carved out by this angle that has a center point in the center. That means this is a central angle.